Hello pre-calculus students, and welcome to the sixth video on half angle and double angle formulas. This is the sixth video and the third example. And this is one where we're going to learn how to use the half angle formula specifically to find the exact value of a given angle. So, or of the cosine, in this case, of 15 degrees, which is not on the unit circle. Okay, so we're going to, first, we're going to recognize that we can only do this if we know twice the angle that we're looking for. So 15 degrees is not on the unit circle. However, 30 degrees is. And that's the only time that you can use this for the half angle formula, and that's because the cosine of 15 degrees is the same thing as the cosine of 30 degrees over 2. Now we have a formula for the cosine of an angle over 2. So the cosine of theta over 2 is, let's just look at our half angle formulas. So half of the identities up here, we have the cosine of an angle over 2 is plus or minus 1 plus cosine of theta over 2. So we're going to write that down right here. So this is going to be plus or minus the square root of 1 plus the cosine of theta over 2. Now, looking at what we have right here, looking at what we have right here, you can kind of tell theta has to be 30 degrees. Now, that's why I said you can only do this if you know twice the angle that's in the argument. So this is 15, and we know all about 30 because it's a special angle on the unit circle. So we know here that theta is 30. And so therefore, what we need here, the cosine of theta, is the cosine of 30 degrees, which is rad 3 over 2. So what we're really given here is we're given plus or minus the square root of 1 plus rad 3 over 2 divided by 2. And I'm going to pause the video and give you a chance to try to simplify that. You're going to have a radical inside of a radical. So that's as simple as we can get it. So we're going to be okay with that. Okay. Now we still have to deal with the plus or minus, but this is what this whole thing simplifies to. I just changed the 1 here into 2 over 2. So I had a common denominator, put them all over one fraction. This is really like 2 over 1, which means I'm going to multiply that numerator by 1 over 2. That's where this 4 comes from. And then the square root of the numerator over the square root of the denominator, but the square root of the denominator is the square root of 4. And that's a perfect square, so that's just 2. Now we still have to think about the plus or minus of this. Now the nice thing about this problem is that if you think about it, you should already know what the sine is, positive or negative, of the cosine of 15. You know that it's an angle, it's a small angle in here, and everything there is going to have, this is a 15 degrees, not theta. Everything in there is going to have a positive cosine, so we're going to choose the positive. So the final answer is just the positive square root 2 plus rad 3 all over 2. Now, something interesting that I want to share about this is that we've already found this value in the past. So we have the cosine of 45 minus 30 is also something that another way of finding the cosine of 15 degrees. So I'm going to pause it and let you guys work this one out, and we're going to compare the two answers, and they're going to look a little different and see what happens. Okay, so try to simplify that using the sum and difference formula. Okay, so a little review of what we did with the sum and difference formulas. Here's the cosine of 45 minus 30. Here's the formula itself, and then just applying that to 45 and 30, and we get here rad 2, these rad 2's and rad 3's over 2's. Okay, and so that simplifies to rad 6 plus rad 2 over 4. By the way, these two radicals cannot be combined, but they can be factored, and sometimes in the back of your book I think that they will do that. So if you take out a common factor of rad 2 and you have inside the parentheses rad 3 plus 1, and if you just distribute this rad 2, you get rad 6, and then rad 2 times 1 is rad 2. So these are equivalent. I usually leave it like this. However, if you see multiple choice that has it like this, you should be able to tell that they're the same thing. But either way you look at it, it doesn't look anything like what we just found using the half angle formula. So we found over here that the cosine of 15 degrees is this mess right here, and using the sum and difference formula we found that it's this mess right here. And now how can that be? Is one of these formulas or one of these identities wrong? Did we do something wrong in our work? And so the answer is in the numbers and the way the numbers are presented. And is it possible that the square root of 6 plus the square root of 2 over 4 could be equal to the square root of 2 plus rad 3 over 2? Could those two numbers be equal? Well, you could put them in a calculator and you could find out that way whether you get the same decimal. But I'm going to just have you try to simplify both of these and see if you get the same thing. And start out by just squaring both sides so we at least get rid of that rad inside of a rad thing. And so I'm going to just get you started here. So this is going to be rad 6 plus rad 2 times itself over 16. And this one would be 2 plus rad 3 over 4. This is about as simple as we can get the right side, but can you simplify the left side and see if they might actually be the same thing? I'm going to pause it and give you a chance to try it out. Okay, so if you square this original left side and you multiply these two together, you get rad 6 times rad 6, and you get two of these inners and outers are the same thing, so 2 rad 12, and rad 2 times rad 2 is 2. And we carry the 16. Combine like terms here. This is actually rad 4 times rad 3. Rad 4 is 2. 2 times 2 is 4. So this is actually, that middle term there is actually 4 rad 3. From there you can factor out a common factor in the numerator of 4. So we have that 4 pulled out. Cancel that 4 with the denominator, and in fact we get 2 plus rad 3 over 4. Which is exactly what we got when we squared our answer from the original, 2 plus rad 3 over 4, once we squared that too. Okay, so they are in fact the same thing. Okay, hope you enjoyed that.